Welcome back, everyone, to the Deep Dive. This time, we're tackling something I think a lot of us have wondered about, especially in academia. Does your early work as a scientist kind of set the stage for your whole career?
Oh, yeah. Definitely an interesting question.
Like, if you start off publishing a ton, are you pretty much guaranteed to be a superstar? Or can someone who's quiet early on suddenly burst onto the scene later?
Right.
Well, we've got some new research that might shed some light on this whole debate.
Oh, cool.
It's a paper called, "Are Scientists Changing Their Research Productivity Classes When They Move Up the Academic Ladder?"
Catchy title.
I know, right?
Yeah.
And it was just published in August of this year.
Oh, wow. So brand new.
Super fresh. It looks specifically at scientists over in Poland across all the STEM fields. So science, tech, engineering, all that good stuff.
Okay, so a pretty wide range of disciplines then.
Yeah, they wanted to see if there were any universal patterns.
Makes sense.
Now, before we jump into the findings, can you give us a quick overview of what this study actually looked at?
Sure. So they followed over 4,000 Polish scientists who eventually became associate professors.
Okay, so like mid-career folks.
Exactly.
Yeah.
And they didn't just look at their work as associate professors. They tracked their publications all the way back to when they were just starting out as assistant professors.
Wow, so they had data going back decades.
Yeah, sometimes up to 40 years, which is pretty incredible when you think about it.
That's a long time to be tracking someone's career. They weren't just looking at how much these scientists were publishing, were they?
No, not just quantity. They also considered the where did these publications end up in the academic world?
Ah, I see. Because publishing in a prestigious journal like Nature or Science is way different than publishing in a smaller, more niche journal.
Exactly. Not all publications are created equal, right?
Okay.
A single paper in one of those top-tier journals can have a massive impact.
So how did they actually measure productivity if they were taking both quantity and quality of publications into account?
Well, they actually used 4 different methods. Some just counted the number of publications, but others gave more weight to those high-impact journals. They also looked at how authorship was shared. Sometimes there's a clear lead author, and other times it's more collaborative.
It sounds like they really wanted to get a nuanced view of how these scientists were performing throughout their careers.
Definitely. It was a very thorough approach.
So the big question is, after all that analysis, what did they find? Is a scientist's productivity really set early on?
Well, the results are pretty interesting. It seems like scientists do tend to stay in their lane, so to speak.
Oh, really?
Yeah, they found that around half of the scientists who were top performers as assistant professors, so publishing a lot in good journals, they continued to be high achievers as associate professors.
So if you start strong, chances are you stay strong.
Interesting.
What about the scientists who weren't publishing as much in those early years?
Yeah, so about a third of them stayed in that lower productivity group as their careers progressed.
Okay, so not everyone who starts off slow stays slow. There's still some hope.
Right, exactly. But the really striking finding was that there were almost no cases of someone jumping from the very bottom of the productivity pack to the very top, or vice versa.
Whoa, that's kind of wild.
Yeah.
So no major Cinderella stories or dramatic falls from grace?
Nope, not really.
Yeah.
And they were careful to make sure this pattern wasn't just because of things like age, gender, or how quickly someone got promoted. They used a statistical technique called logistic regression analysis to really control for those factors.
So it seems like those early years really do matter. But I'm guessing there were some differences between scientists working in different areas of science, right?
You're right, there were. For example, over 50% of those top-performing assistant professors in the natural sciences kept that top spot as they moved up. That was the highest rate of any field they looked at.
So for all the aspiring natural scientists out there, it sounds like building a strong foundation early on is crucial.
Yeah, definitely something to keep in mind.
This is all giving me a lot to think about. And probably a lot to think about for our listeners, too.
Absolutely.
We've just scratched the surface here, haven't we?
Oh, yeah, definitely. There's a lot more to unpack.
Okay, well, let's take a quick break. And when we come back, we'll dive deeper into the implications of all this. What does it mean for how we evaluate scientists? And does this stickiness in productivity affect the kind of breakthroughs we see in science? All that and more when we return.
Sounds good.
Okay, so we've seen the scientists tend to stick to their productivity tracks, which is pretty fascinating in itself. But it also raises some really big questions, doesn't it?
Oh, absolutely.
Like if we know that early career performance is such a strong predictor of long-term success, what does that mean for how we evaluate scientists? Should we be putting more weight on those early publications when we're hiring someone or deciding who gets funding?
Yeah, that's a really important point. I mean, this research could really shake things up for hiring committees and funding agencies. Maybe instead of just looking at someone's total number of publications, we should be focusing more on the trajectory of their work.
Right, like are they consistently publishing in those top-tier journals?
Exactly.
Yeah.
That might be a much better indicator of their potential than just a raw count of publications.
It's like looking at an athlete's progress over time, not just their most recent win.
Right, exactly. You want to see that upward trend.
And this all has implications beyond just hiring decisions, right?
Oh, for sure.
If scientists really do tend to stay in their lane, does that mean we're less likely to see those big game-changing breakthroughs?
That's a really interesting question. And it's one that this particular study doesn't fully address. I mean, they focus on productivity, but they didn't really delve into the impact of that work.
Right, so it's possible that someone who's consistently publishing in their specific niche might be making steady progress, but not necessarily the kind that leads to a major paradigm shift.
Exactly. They might be refining existing knowledge, but not revolutionizing the field.
So maybe we need to rethink how we reward and incentivize scientists if we want to see more of those groundbreaking discoveries.
I think so. Maybe we should be focusing less on just the sheer number of publications and more on the quality, the potential for real-world impact, or even the boldness of the research.
I like that. Rewarding scientists for taking risks and thinking outside the box.
Yeah, because those are often the ingredients for those truly transformative breakthroughs.
Okay, so we've talked about the high achievers and the folks who might be struggling to keep up. But what about all those scientists who fall somewhere in the middle?
Oh, that's a great question. And actually, that middle group was the one that showed the most variability in their careers. Some stayed right in that middle zone, while others moved up or down the productivity ladder.
So there's still room for movement and growth, even if those huge leaps from the bottom to the top are pretty rare.
Right. And I think that highlights the importance of factors beyond just raw talent or ability. Well, things like mentorship, having access to resources, and working in a supportive environment can all play a role in shaping a scientist's career trajectory.
It really underscores the need to create a scientific culture that nurtures talent at all levels and recognizes that there are many different paths to success in science.
Absolutely. And for any early career researchers listening, don't get discouraged if you're not publishing at the same rate as some of your peers. Consistency, perseverance, and a passion for your work can take you a long way.
And you never know, you might be one of those rare scientists who defies the odds and makes a major leap forward in your field. But there's something else that struck me about this study. They had access to so much data about each scientist, not just their publications, right?
Oh, yeah, they had a wealth of information. They knew when each scientist earned their doctorate, when they got promoted, their age, their gender. Having that level of detail allowed them to really tease out the influence of those personal and professional milestones on productivity.
It's like getting a behind-the-scenes look at how scientific careers actually unfold, beyond just the raw numbers.
And what's remarkable is that even with all those individual variations, those core patterns of productivity persistence still held strong.
It suggests that there were some fundamental forces at play here, shaping how scientists navigate their careers. But I think it's also important to remember that this study was done on Polish scientists.
Oh, good point.
We need to be careful about generalizing these findings to scientists in other countries.
Right. Different countries have different academic systems, different cultures around research, and different funding models. It'd be fascinating to see if these same patterns hold true in other contexts.
And that's where you, our listeners, come in.
Yes. We'd love to hear from you. Do you think these findings resonate with your own experiences or what you've observed in your field?
Have you seen evidence of this productivity stickiness in your own career or among your colleagues? The beauty of the deep dive is that it's a conversation, a shared journey of discovery.
We're all learning together here.
And speaking of learning, there's another methodological detail I wanted to highlight before we move on. Remember how the researchers normalized publication counts based on journal prestige?
Oh, yes. That was a key strength of this study. They didn't treat all publications as equal. They factored in the hierarchy of academic journals.
Right, because publishing in a top-tier journal takes more effort, more rigor, and often takes longer than publishing in a less prestigious outlet. It's like acknowledging that running a marathon takes more training and dedication than a 5K race. Both are achievements, but the level of effort is different.
Exactly. And by taking that journal hierarchy into account, the researchers were able to paint a much more accurate picture of actual scientific productivity. They weren't just looking at raw publication counts.
Which makes their findings even more compelling. It's not just about quantity, it's about the quality and impact of the work. And this brings up another interesting question. Should we be placing more emphasis on publishing in those high-impact journals? Or should we be valuing a wider range of outputs, like data sharing, software development, or public engagement?
Yeah, that's a tough question. But definitely something worth discussing, especially as we think about the future of science and how we support research.
For sure, for sure.
I mean, we've covered so much today, those long-term trends in scientific careers, how common those patterns of productivity are, and what it all means for fostering innovation.
Oh yeah, it's been quite a deep dive.
But what does this all mean for you, our listeners out there? Whether you're a scientist yourself, a student just starting out, or just someone fascinated by how science works, there are some key takeaways here.
I think so too.
It's a good reminder that careers in science are shaped by so many different things. Talent matters, hard work matters, but so do the opportunities you get, the mentors you have, and yeah, even a little bit of luck plays a role. Oh yeah, for sure. Luck is definitely part of the equation.
And even though this research suggests that, there are some pretty clear trends in how a scientist's output changes over time, it's not like it predicts your entire career path.
Right, it's not a crystal ball or anything.
Right, more like a map with lots of different routes and possibilities.
Yeah.
You get to choose your own path and how you want to make an impact.
And the impact you make is what really matters in the end, I think.
Couldn't agree more.
Yeah.
Now, one thing this research really pushes us to think about is how we can encourage scientists to be more innovative.
Mm-hmm.
How do we measure success in a way that values more than just the number of publications? And how can we best support researchers throughout their entire careers?
Yeah. Those are really important questions, especially given what we've learned about how productivity seems to play out over time.
Exactly. So as we wrap up today's deep dives, we want to leave you with one final thought-provoking question. Something to mull over as you go about your day.
All right, let's hear it.
If scientists do tend to stick to their productivity tracks, what does that mean for those brand new areas of science, the ones just starting to emerge? The fields that are ripe for disruption and fresh thinking.
Yeah, that's a good one.
How do we ensure that those new fields attract the best and brightest minds, the scientists who are going to push boundaries and challenge the status quo?
Yeah, especially since those are often the areas where the most groundbreaking discoveries happen.
Exactly. It's a tough question with no easy answers, but it's definitely something we need to be thinking about, especially as science continues to evolve at such a rapid pace.
Especially now, yeah.
Well, that's all the time we have for today. Thanks for joining us on the Deep Dive.
It's been fun.
And until next time, keep exploring, keep learning, and keep diving deep into those fascinating corners of knowledge.